All right, so the last piece of the chapter is a two proportion z-test. And so this is going to answer the question, is there truly a difference between this group's proportion and this group's proportion? So we saw in the last video, if our confidence interval has the value 0 in it, that means that there is no difference. The proportion of female binge drinkers and the proportion of male binge drinkers, when I subtract those numbers, there's no difference. And so that kind of brings us into what we would state as we begin a two proportion z-test. So if I want to answer the question, is there truly a difference between males and females that wear their seatbelts? I want to state a null and an alternative. We saw on the last Frappy, just stating a null and the alternative hypotheses gets you that point. And so we want to pick up that point while we can. So the null, if we remember, this is the Dole hypothesis. So this is just, there is no difference between the groups. Okay, so nothing interesting. Males and females wear their seatbelts the same amount of time. Well, what would that look like? That would be the statement that P1 is equal to P2. Okay, the other way you see this written is our null hypothesis would be, the other way we see this written is P, I cannot get this down right, okay. That P1 minus P2 is 0. And that's saying the exact same thing, just a little algebra from that statement. So if there's no difference, then they're the same. Or when I subtract them from each other, I get 0. So you see it written both ways. My personal preference and the way you're going to see me write it is this one over here. That just intuitively makes sense. And that way we remember that it's always just got the equal sign right there in between them. But this way is perfectly acceptable, and you'll see that in books and such as well. Okay, so for the alternative states there is a difference. Okay, so maybe this is more males wear seatbelts, or more females wear seatbelts, or there's some, well, I guess those are the only two types of differences, but we're unsure. We're unsure, but think there's some difference. So this is where the notation comes in, because I'm either going to write, for my alternative, I'm either going to write P1 is greater than P2, or I'm going to write that P1 is less than P2, or I'm just going to state that P1 is not equal to P2. So those two proportions are not the same. Okay, the conditions we have to check in our state step are identical to the ones we checked for a one proportion z interval. So I'm going to write these down real quick, but we'll see them in an example on the next page. So this new one, groups must be independent. Have to. So simple random sample for group 1 and simple random sample for group 2. Okay, second condition, success failures. So at least 10 successes and 10 failures for group 1. And we'll just go ahead copy that exact statement since we just do it twice, again for group 2. And then finally, the third condition, N1 needs to be less than 10% of group 1 population. And N2 needs to be less than 10% of the group 2 population. Okay? And some of you might be wondering if it's still less than or equal to, and it is. But my keyboard doesn't have a less than or equal to sign. But typically we're well under the 10%, so less than or equal to, and it's just a small little detail there. Okay, so that's it for our state step. Just like we've seen, we want to state a null, we want to state an alternative, and then we want to check all of our conditions. Okay, so once that's been done, we get to plan this. So all I'm going to do here is state, I guess there's more just stating for the plan step. I'm going to let the reader know the conditions have been met. Well, why did I do that? To show that it's going to follow a normal model. Then I'm going to tell the reader that I am going to conduct a 1 proportion z test. Okay, so, or sorry, excuse me, a 2 proportion z test. So we've got z intervals and z tests. Z intervals, I'm setting up a confidence interval. Z tests, I'm testing a hypothesis. So hopefully those are fairly straightforward. Okay, so for the do step, calculating my z-score, we see this is going to be datum minus mean over standard deviation, right? So with that, let me make the lines nice and small for this. So we should end up with P1 hat minus P2 hat, right? That's our datum, that's what we observe, minus P1 minus P2, that value, which is our mean, the center for that, sampling distribution, all over the square root of P1 Q1 over N1 plus P2 Q2 over N2. There's a problem with that though. This right up here, this standard deviation right here on the bottom, didn't we say in our hypothesis that P1 and P2 were the same number? So then why over here am I saying that this value and this value are going to be different? So it turns out this is not how we can calculate our z-score. So let me write this down. Here's how we're thinking about it. So we said P1 and P2 were the same. So if we're saying the proportions are the same, we do something called pooling. And I kind of like this vocabulary word because hopefully it makes sense to you like it does to me. If I'm talking about males and females wearing their seatbelts, well, let's draw a little picture. So over here, I have males. Okay. And if I say that this proportion of them wear their seatbelts, well, my null hypothesis is that in a group of females, the proportion's the same. So I should see the same amount. And so what we do in pooling is we put them all together. And so now I'm just saying that that proportion of the whole group. So the total number of people who wear seatbelts over the total number of people in the study. Let me rewrite that so a little more legible. Okay, so that's how we calculate that standard deviation. If I'm saying that all of these people are, that both of these groups have the same proportion, well then if I put them all into one group, that proportion should be the same. So here's how we do that. That's just going to be x1 plus x2, so total number of people who wear seatbelts, over n1 plus n2. And this gives us our pooled proportion. Okay. That's a really big idea right here. Okay, so once we find, like we saw in the last chapter, once we find that z-score, we're going to use, or actually let's go ahead and, I guess I haven't even written down the correct formula. All we have right now is our incorrect z-score formula. So the correct way to calculate the z-score well, we have p hat 1 minus p2 hat. That's still our statistic. That's our observed difference. And then I subtract p1 minus p2. And that's going to be all over this pooled proportion. Sorry, the standard deviation using the pooled proportion. So I'll go ahead and write that down. Little subscript. Okay, so we have our pooled p hat and our pooled q hat over n1. And then we have our pooled p hat and our pooled q hat. Because remember, I'm now saying that those are the same quantities over n2. Okay. And so the only other thing we need to look at with this formula is this value up here. So this value up here, I said that P1 minus P2 in my null hypothesis, I said that that value was 0. So when all is said and done, the only thing we're actually calculating for a z, for a test statistic, is we're going to do P1 minus, sorry, P hat for the first group minus P hat for the second group, minus 0, well, I don't have to include that. That's just 0. Over the standard error using the pooled proportion. Okay, and so once I've found that test statistic now I get to find my p-value. So p-value, how do I interpret that? We've spent quite a bit of time talking about the interpretation of p-value. So hopefully you have a little bit of space left. So the p-value interpretation is going to be if the true difference is blank, then the probability of seeing a difference in sample proportions of blank is blank. That's kind of your template, and that's the exact same that we saw in the last chapter. So if the true difference is 0, because that's our null, right? So if the true difference is 0, then the probability of seeing a difference in sample proportions of, let's actually extend this just a little bit. Okay, so of seeing a difference of whatever I calculated is your p-value. That's how we interpret that. So if there really is no difference, the probability of me seeing a difference of this size is blank. That's your p-value. All right, and for the conclude step, more templates. So we reject or we fail to reject because the p-value, we always rely on that p-value to tell us our decision. Okay, so whatever the p-value is, that tells us if we rejected or failed to reject it. And then we state that we have sufficient. If we rejected, then we did have enough evidence, or we have insufficient evidence to say the proportion of blank is and I'll put this all together in just a second. Okay. So what is all this saying? We reject or we fail to reject. We have sufficient evidence to say the proportion of, well, this is group 1 in context. Okay, so whatever that alternative was that I stated, that's what I've just found evidence for. So it's either greater than, less than, or I'll write this out with the pen. Any one of those two, and that, or any one of those three. And for that, all we want to do is look back to the alternative hypothesis. That's going to tell us which one we just found evidence or which one we didn't find evidence for. And then this is just going to be the proportion of group 2 in context. And so what might that look like? By the end of the next example, we'll either be able to say we reject the null because the p-value is lower than the alpha level. We have sufficient evidence to say the proportion of males who wear their seatbelt. So males who wear their seatbelt is group 1 in context. The proportion of males who wear their seatbelt is greater than, or less than, or is different than the proportion of females who wear their seatbelt. And so that's the comparison there. We're saying we don't believe the difference is actually 0. We believe it's greater than or less than or different than. All right, so we are not actually, you survived the explanation of pooling and you survived the explanation of our new z-score formula, but we are not going to calculate this by hand. We have a calculator, and so the do step via calculator is what we'll use for the next example. Okay, so at this point, we've reached 1 hour of video, and with different pausing times, I think we've reached the max that you'll complete of the notes with the sub. I'll be back tomorrow, and we will finish these up and go through one example. So I will see you then.